Hello everyone, welcome to the video lecture series of data structure. Our today's topic is introduction to array and 1D array representation of memory and 2D array representation. And we will also see about the how to calculate the memory address for 1D array. Myself, Janisha, your instructor. So let's start with the outlines. See, our today's outlines are the first we're gonna see about the array, then memory representation in array, then 1D array, example, memory representation of 2D array. So students, now it's time to tell me that what do you mean by the array? Students, array is nothing but is a collection of homogeneous elements where each and every elements are stored in a sequential manner. Okay, so when the elements are stored in a sequential manner and in the continuous form in the memory, then that is known as an array. So here I am just showing you one example that, sir, what do you mean by the homogeneous? Homogeneous means, students, the same type, and elements here stored in a continuous fashion. Here in array, index starts from 0. Make sure. Then let's go ahead. Syntax. That's how to define an array. So students, we can define an array like first we need to write data type, then array name, then size. Data type can be integer, float, character, animal. Array name should be meaningful. Make sure if you want to make an array of students, then just give it a name like std, student, or students. Fine. And in square brackets we are writing the size of the array. Size of the array like 5, 10, anything. So if I want to declare an array of size 10 of integer type, then it can be like example integer ARR of 10. Fine. Now let's go ahead. See, the next topic is memory representation in 1D array. So students, here you can see that the integer array of 5. Students, if I am taking the elements of 5, array with size 5, then it is like a integer a of 5. So integer array contains 5 elements. The elements are like this. You can see in this figure like 10, 20, 30, 40 and 50. Students, you know the array stored in a continuous memory allocations. So if my first element address is 1000, then the next can be incremented as per its size. Is such like if this is our array of integer type. So the next element size can be 2-byte incremented like 1002, 1004, 6, 8, such like this. So the first element of array is known as a of 0. Here our variable name is a and the element situated at index 0. That's why the first element is a of 0. Fine. So in green color you can see the array indices, in the brown color you can see like the array addresses. Okay, fine. Now the next, students, a of 0 is the first element, which is also known as the base element. Fine, because array starts from a of 0. Now the element stored at a of 0 is 10 and address of a of 0 is 1000. Next element addresses 1002, which is a of 1. So students, here you can easily say that if my the array is of integer type, then the elements can be incremented, the address can be incremented in 2 bytes. But what happens if I have the floating type of an array? Students, if you have a floating type array, then your addresses can be incremented 4 bytes. Like a of 0 is at 1000, then a of 1 can be at 1004, 1008, 1012. Okay. Now, what about the base address? whatever the address of the first element is known as base address. Make it clear. The address of the first element of the array is known as base address. Here the base address is 1000. Now the base address is address of the first a of 0 address is 1000. Now how many memory occupied by this array? Students, the total memory occupied by this whole A array is 10 bytes. Why? Because there are 5 elements are there, each and every element of type integer, and integer contains 2 bytes, so that becomes 10 bytes. So if the array is of floating type, then the memory can be 5 into 4, which is equal to 20 bytes. Fine. So now let's start with the memory calculation or example of 1D array. Students, here you can see the question is like this: to calculate the address of element in single dimensional array. Fine. Students, formula for that to calculate the address of element in single dimensional array is a of I is equal to base address BA. See, a of I is equal to base address, BA stands for base address, plus I minus L star size. Star, that means multiplication. Do not forget that. So I, that means index, on which the address we want to find it out. Then L means lower bound. Okay, sir, what do you mean by the lower bound? Students, if we have an array of size 5, then index starts from 0. That's why the elements goes like this: a of 0, 1, 2, 3 and 4. So the 0 is known as lower bound of the array, and 4 is known as upper bound of the array. Fine. So now just the I is index, BA that means base address, L that means lower bound, and the total number of elements are in the array is U minus L plus 1. Just make sure that please focus on this formula, that U minus L plus 1. U means upper bound, L means lower bound, plus 1. That is the total size of the elements in array. Fine. So let's start with the example. The question is, calculate the address of A of 6. Calculate the address of A of 6 if the given array is A of 9. So here we have the total size of the elements, A of 9. Array is A of 9. So total 9 elements are there. Fine. What we need to find it out? We need to find out the address of A of 6. So our I becomes 6. Students, base address is also given. Base address is 1000 and the array is of integer type array. So just put all the given data into the elements, such like the first one is I is equal to 6, size of the array is 9. Okay, fine. Then the base address is 1000, and what exactly size? SIZE. This size is known as size of the element, not array. Fine. Here the size of the element is 2 bytes, just because it is of type an integer type an array. Fine. So size is equal to 2 and array is A of 9. So students, in A of 9 array, the element starts from index 0 and the upper bound is 8. So L is equal to 0 and U is equal to 8. Fine. So next is, we put these values in the formula. The formula is A of I is equal to base address plus I minus L multiplied by size. Base address is 1000, I 6, L 0. Obviously lower bound is 0. Then size is equal to 2. So our answer is 1062. Another question is there, that how many total elements are there. You can easily find it out with the formula U minus L plus 1, or in this you can easily get it that 9 elements are there. But how can we get it from the formula? Upper bound, students, upper bound is, upper bound is 8 minus L is 0 plus 1. So 8 plus 1 becomes 9. So here 9 elements are there. Now I am taking the next example. Next example is to calculate the address of elements in single dimensional array. Example 2. See, must read the question first. The question is, calculate the address of m of minus 3. M of minus 3, where the array is m of minus 9 dot 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 7. Students, here m of minus 9 triple dot 7 This is the range of the array indexes. Range of array indexes. -9 is the lower bound and 7 is the upper bound. So make sure that here this -9 and 7 is not this two-dimensional array, but it shows the single dimensional array but the range of indexes. Fine. So here we need to find out the address of m of -3. The given array is m of -9 to 7. -9 dot 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 7, that means -9 to 7 with the base address 1002. Fine. So it can be a floating type array. Students, the array type is also given, it's a floating type array. Okay. Also calculate the number of elements in array. So we need to also calculate the number of elements in the array. So in this question, students, we have each and every data. Just put it down in the elements formula. The formula is total number of elements are in array u minus l plus 1. U minus l plus 1, which is equal to like 7 minus 9 plus 1. 7 minus 9 plus 1, it becomes 17. So here you can see that there are 17 elements are there. 17 elements are there. Fine. I is equal to, what do you mean by the I? I is equal to -3 because we need to find the address of m of -3. Okay, lower bound is -9, upper bound is 7 and size is 4. Fine. So just put this whole thing into the formula. The formula is a of I is equal to base address plus I minus L multiplied by size. A of I, that means m of minus 3. So m of -3 is equal to base address. Students, base address is 1002. So 1002 plus I that means -3 minus L. 3 minus 9. Calculating this sum, solve it and you get the answer 1026. So students, 1026 is our address of the element m of -3. Now go ahead. The next topic is memory representation of 2D array. This is our last topic of today's lecture. So, okay, first, how can you define or how can you write the 2D array? You can write it like this: integer a of 33. Integer a of 33, it means data type, then variable name, then size of row, then size of column. So here integer a of 33, it means it is a two-dimensional array. So a is a two-dimensional array. Students, here see this table or this matrices. This matrix is nothing but it's a two-dimensional array. I am just showing you how can I represent these two-dimensional array matrices into the memory. Fine. The first element at 0, 0 is at 10, then 20, then 30. So 10, 20, 30, then 40, 50, 60, 70, 80, 90. So here 3 cross 3 matrix, total we have 9 elements. Fine. So now what next? Students, we can store the data or we can represent the 2D array in memory with two different ways. The first way is row major. Okay. What do you mean by row major? Students, this representation of data is known as row major. In row major, we are just inserting the element row wise. Okay. So just see this. 10 to 90. I'm just writing the string from 10 to 90. And then what happens? 10, the address is 10 is C. First element is 10, which is known as A of 00. The next is 20, which is A of 01. Third will become A of 02. So when you are just inserting the data according to the row wise, then it becomes row major. Here are the column major. The column major data are inserted such like this. In column major, the data elements are inserted column wise. But if we just considering the column data for this particular matrices, then the data elements are for column major like 10, 40, 70, then 20, 50, 80, then 30, 60, 90. So such like this, students, we are just inserting the data in the memory according to the column wise. So what will become the indexes for that? See now 10, after that I am just writing 40. See, after 10, after that I am writing 40. After that I am writing 70 because this is a column major, not row major. Fine. So the next is, what do you mean by the row major? Row major, students, it means row major where the elements are stored into the according to row wise. In column major, the elements are stored according to the column wise. So students, in this lecture we learn about the array, introduction of the array, then how can we represent the elements in 1D array and 2D array. We have also seen the examples of 1D array, that how can we calculate the memory address in 1D array. So if you have any doubt in this lecture, then please feel free to ask me. Thank you so much.